Welcome to the last day at TechEd, or buongiorno, as I should probably say today. It was a very tragic loss. I blame it all on the German coach. Okay, enough with all the sorrow. This session is originally titled Achieving Enterprise Integration Patterns with Windows Azure Service Bus. The subtitle is a little bigger. Service Bus Solution Patterns is 3 sessions in one. The first one is I'm going to talk about a number of customer scenarios that we're seeing with Service Bus, some exemplary scenarios, so that you get an idea what you can do with Service Bus and what we see customers doing with Service Bus. The second section is going to be about scalability patterns and something that we see as a trend not only in the industry, but also something that we repeatedly are talking about in forms of patterns, specifically when it comes to connecting a large number of devices, including applications, apps that run on phones, but also industrial, commercial devices, and how to tackle them. So there is some, actually, Service Bus independent scalability advice here as well. And the third section is about the core of what the title is about, and that's a number of enterprise integration patterns. I'm going to go and try to balance them. So some customer use cases, integration patterns. I'm going to talk a little bit about the notion of provisioning, and then particular patterns as they relate to Service Bus messaging towards the end, so that you know what's coming. So effectively, it's 3 talks in one, as I just said. 20 minutes, 20 minutes, 20 minutes, just about, or 25 each, to give you a broad overview of what's happening kind of in the customer world around Service Bus. So before we go there, the enterprise goals, as per Gregor Hope's book. Gregor Hope is German, works for Google, lives in California, and he wrote this brilliant book. In case you don't have that, that's a very very good book to have, and it's one of the standard books kind of in the space when you have to deal with enterprise software. And the common enterprise goals are information portals, data replication, shared business functions, service-oriented architectures, distributed business processes, business-to-business integration. And we're covering a lot of those with Service Bus. We're playing a role in many of those. And future enterprise goals, as per me or per us, is that we believe that in the future you will have to reach consumers in large scale. Today, enterprise software is constrained to relatively small audiences. And when I say small audiences, I mean 10,000 people or 50,000 people, which is a lot. And you have to scale to your application to 5,000, 10,000 concurrent users. But when you start comparing this against what a startup that writes an iPhone app needs to do in terms of scalability for a backend for their system, it pales in comparison. If you're writing something, it doesn't need to be Instagram big, but if you're writing something that has reasonable traction, you get immediately 500,000, a million downloads across the world of your application. And if you have backend components, they need to scale to those numbers. So it's important that if you're building apps that interface directly with the consumers, with your customers, that you actually are ready for that kind of scalability challenge. And also, you need to meet the business needs with ever higher agility, but that's something that's not new to you. So we need to be even faster delivering, and as we go into a world where we have DevOps as a trend, where we are running systems that we're developing, we're taking the responsibility onto ourselves. We're going to be more agile and faster turning around services, and we're no longer going to be stuck in the cycles where you have a year until you can finish a project. The expectations are going to be that you can turn those things around much faster. So the enterprise is going to speed up because the rest of the world is speeding up as well. Service Bus is kind of the connectivity fabric that we have in Windows Azure for integrating between all kinds of things that talk network. And we're an application-level integration bus. We provide PubSub, we provide queues, we provide relays, we provide naming, firewall traversal. We're providing abstractions to allow things to talk to each other. And so I presented that in a little more detail in my overview session. But I want to go in and talk about some customer use cases today, illustrating how our customers are using us, or how ISVs are using us. So this is odd. Sorry. Oops. Sorry for that. So first one is web services for retailers. There is a company in Italy. Congratulations to Bed & Shop Systems on the football. And they're making web services for retailers. What they're doing is they have a combination of services that run in Windows Azure and on-premises applications that run on cashier's desk, and then also run at the retailer's data center. And data center in the widest possible sense. It doesn't need to be an isolated facility, but a place where you can run things. In the retail space, what they're doing here, what they're helping with, what Bedin helps with, is distribution of all kinds of information that are relative to retail. That may be adjusting prices, it may be updating the catalog, it may be processing orders, and making sure that the store is properly stocked. On the retail sites, as the shop is selling things and the stock levels of the respective wares that they have and they sell depletes, they have to go and effectively resupply the store. So all the levels of how they sell things are being reported from the cashier's registers, and then also by counting whatever is on the shelf, and then reported back into the retailer's data center. The way they do this is they go through a queue. So they create a queue per shop, or they create a queue per region. I think they actually create a queue per shop, and that's where the cash registers, the computers in the store, go and report the data in. And then they have web services that are sitting up in Windows Azure, which actually do the work of rolling the data up. So that's where the actual solution sits. That then goes and integrates with the services that's sitting at the retailer's data center. So the retailer's data center, that's where they have the line of business applications that are actually performing the ERP systems, etc., that are performing all the operations. What Bedin provides here is kind of the services to actually manage the flow and manage the integration with the point of sale systems. So orders go into the service instances, then they go through the relay from the service down to the LOB service and send the data there. The relay here takes the role of being an externalized DMZ for the retailer's data center. So in the retailer's data center, they have a number of services. Those services are usually not exposed for external use, but what they're doing here is they're exposing those services through the relay out to Service Bus, which then can be consumed from the SaaS application that sits out in Windows Azure. And there's two models for creating those applications. I'm illustrating both. The first one is a per-tenant web service, where you're deploying effectively on a per-customer basis one service. You can highly customize it. You're effectively building a solution on a customer basis. Or you have a multi-tenant web service where you're running the same logic, but you're effectively dividing your service on a customer-by-customer basis and giving each customer a view of your service. If you take a look at Windows Azure, for instance, you get your portal and you get your service bus and you get your storage, even though it's a multi-tenant system. So you get a projection of that service that's customized for you. So there's two models, and of course, the service bus model works with both. From the LOB system, in the LOB system, you can do price adjustments or catalog adjustments. So if you're deciding that Coca-Cola is going to be 10 cents more expensive in a certain city, then you go and adjust the price, and then that price adjustment can now be replicated through the catalog distribution topic, also in Service Bus, and you can have multiple subscribers. Here in this case, actually every single cash register has a subscription into Service Bus, and there's one message pushed in about the new price, and that's targeted using rules. We're going to see all those things, using rules to a particular shop, to a particular region, to a particular neighborhood, and then send out, and then that automatically gets updated. So effectively what they're doing is they're using Service Bus, they're using this cloud solution to create the connectivity, not only the connectivity, but the information flow between all their sites that they have everywhere around a region. And Bedin offers this as an international service, so you can go there and have your point of sale systems hooked up through Bedin shop systems, and they will go and communicate in that way. So solution profiles, point of sale applications, they send the messages to the queues. The on-premises data access is done for sensitive data into the customer's data center, and then the notification Service Bus, and they're using Service Bus queues and topics. And they were actually one of the first users of Service Bus queues and topics. We actually onboarded them while we were still in private beta, and presented with them together at the Build conference last year. Another one is a company called Green Button. And Green Button is providing a SaaS service for dynamic compute workloads. What that means is the following. Pixar, for instance, the movie company, needs to render a lot of pictures. They need to render the movie out of models. And the way they do this, in part, is through the Green Button's compute farm. The Green Button's compute farm is built on top of Windows Azure. So what they're doing is they're creating a multi-tenant compute farm where you can go and define a job, and they have a number of job processors that they have in that farm for digital rendering and for other jobs. So they have specific compute workloads that Green Button stages in Windows Azure. And then you take a job and then submit that job into the environment. And then that job gets processed and you get the results out of it. And then you pay for that slice of compute time. So it's not a model where you are deploying an application, but you're actually giving a job to a pre-built kind of compute jobs that are existing, and you're submitting the job, and then you pay for them. So the way how this works is from the client side, the green thing, you go and send the job data into a blob, and then in step 2, you notify, you effectively have it, now I have URI, and then you pass that into the job queue. The controller service will go and pick this up from the job queue and then find one of the processing instances. In step number 4, what they're doing is they're actually using the relay. Service Bus gives you the capability not only to do the queues and also the relay down to the on-premises instances, but it gives you something that's otherwise difficult, and that is individual addressability for any compute node. So it gives you an abstraction where you can now have a named endpoint inside of Windows Azure or inside any environment where you can actually use the relay to go and bridge in. So the relay also gives you individual addressability for VMs which would otherwise be behind firewalls or behind a load balancer as they are in Windows Azure. So you can go across deployments in Windows Azure, and you can go and individually address worker roles by hooking them up into the relay. So once a processing instance has a job assigned, it will then go and grab the data out of the job store, and then will process the job. And while all that happens, there's a topic that data is being pumped into about the status of the job, and that's where the monitoring, so the monitoring guys from the SaaS provider, as well as the customer, can go and see how the data is doing, because it's a broadcast pattern that's being applied here. There's another service that we have. Another thing. Whoops. Why is this moving? Okay. The room is moving. Do we have an earthquake? So there's another service that we see, and that's a who has what data about me service. What they're doing is, this slide used to be called personal information tracking, but that's the wrong picture. Effectively, what they're doing is you can give them your name and personal information about you, and then they're going to several hundred websites that track social information, etc., and they will go and aggregate and show you all that data. So if you kind of don't know where you are all listed and what kind of directories there are, because everybody is now trying to be social without asking you, they're going to track that down. And that's a feature, that's a service you can pay for. They have a free tier where you have 20 sites that they go to, and there's a paid tier where they go and look at like 700 sites. So you can keep track where you are, and then you can, I believe, also unsubscribe from a lot of those services. So the way they do that is you come in from the consumer website and say, yes, I want to go and send you off and see what data the other sites have about me. So they go through a web role instance and send data through a request queue to a scheduler. That scheduler then goes to a topic, and you have these data services, and the data services are the services which actually go and take the job and now go off to an external site and go and grab whatever data is there about you. They search the site for you, and they do that in parallel. So they do a fan out of one job to N processors, where they go and collect the data for you, and then they're going to get that data back. The way they get that data back is they give the data services, that are kind of the proxies, a reply queue address for that web role. And reply queue address for that web role, where the web role is now listening for a particular, on that thread that you're sitting on effectively, listening for specific events. That's done with sessions. It's a pattern that we're also going to see towards the end, where I sent the data in and I give a correlation ID. That correlation ID is now used to send data into a single queue, all with the same session ID. That session ID allows pinning of that work set, of that set of results, even it comes from multiple parties, to one particular receiver on one particular logical thread in one particular web role. So that's what we call an aggregator, and we're using that with sessions. So I'm going to show you that towards the end. So those were some customer patterns that we see, a variety of also in the introduction session, in the overview session. I showed you another one about LexisNexis, where we had a mobile services gateway that's reaching into individual sites using the relay. So there's a broad variety of patterns that you can do using Service Bus. Here's another one. Scaling things out. And before we go into the details patterns, let's talk about the little wheels, the little gears up on top. The little gears represent something like this. This is the .NET Gadgeteer SDK, and there's a little device that's being modeled here. And I will show you that device. Let's go and get to the camera app. There it is. And so I have one of those devices here. So let's see. This is a relay. What you can do with the relay is you can go and turn some electronic device on or off, because this is just has a power switch, effectively. 6 power switches to be precise. There's a little display that has turned off because the device is now sour that I have touched its circuits. There's a main board with a processor. There's a power supply. Ooh, I'm now tangling it. There's a power supply. There's a joystick. And there is a, where are you? There. Now it's tangled. Now I have to throw it away. Here is a temperature sensor. All of this together makes, quite obviously, an air conditioner. Let me explain that to you. So we have a humidity. So we have this. The power supply here. We have the humidity sensor here. We have the relay here. We have the Ethernet connection here. We have the display here. And there is the main board, and that is the joystick. So in the .NET Gadgeteer SDK, there's a website where you can go and find all those things. You can, for that, you can go and buy these pieces of hardware. It's modular hardware that you can buy and put together. And this is a prototyping kit for devices. So this together represents a simple air conditioning or a thermostat, because what we'll do is we have some logic that will sense the temperature, and then based on the temperature, we'll turn a fan on or off, which is what it is doing through the relay. Now, the nice thing is, if you think about it, it'd be really cool if we could go and get some telemetry from this thing, if we deploy very many of those somewhere, and see, what's the temperature like in the corners of the building, what's the power consumption like of the air conditioning system. So if we actually could get all that data into a central system. It would also be nice if we could remotely go and control those things. And if you think about what that means in the consumer environment, right? You have a air conditioning, or you have some heating systems, you have some home control systems, and it'd be nice if you could combine this with things like a GPS system in your car, where the car knows that you're approaching the house, and then it can turn the air conditioning on, so that it's nice and cozy when you get home. There's all kinds of interesting things that are going on, and we're actually talking to people about these kinds of devices, about household appliances, about cars. So this is not crazy. But when you do this, and when you build devices like this, and you put them into, this is a prototype thing, right? But now you actually create a board, and you put that into consumer electronics or into a household appliance, all of a sudden you have a problem that you're selling 100,000 of those things, or 200,000 of those things. So how are you going to scale things out? So we'll talk about that first in theory, and then we're going to show you a little bit of the code that's behind this. So the general problem, let's talk about air conditioners here, and let's take a scenario of the United States and heat waves. It's very timely, because today they're going to have a really bad heat wave. It's going to be 42, 43 degrees, and I mean Celsius, in most of the southern United States. I'm really glad I live in Seattle. And because Seattle is going to have 20 degrees, something like this, but it's just a small corner, and the rest of the country is going to be scorched. In those times, what happens is that the Americans love being in the cool. And when I say cool, I mean cool, like 17 or 16 degrees. And of course, they're going to run their air conditioning like crazy, and the power grid is not built for that purpose. So we're going to see happy brownouts today, where the power is going out, first world country. So the electricity companies are actually trying to, this is the worst nightmare for the electricity companies, because they want to effectively keep the grid running, but for that they would have to cut off entire neighborhoods. So brownouts is effectively the electricity company cutting power to entire neighborhoods, because that's the only remedy that they have. So it'd be nice if the power company could actually go in and say, all right, so your air conditioning is now cooling you down to 17 degrees. We don't have enough power for this. You're going to snap to 25 or 28 degrees. That's better than you sitting in the 42 degrees that it's going to be otherwise. So that's what that scenario is. And I've been talking to a number of smart grid and power company providers, and they would surely like this. They think that there's some privacy concerns to talk through, but take that as an example. We have other examples for, let's say, connected car scenarios, where you want to be able to just start your car or check whether your car is locked, or you want to turn on the heat on your car before you go outside if it's winter. So there's all kinds of scenarios where you want to do remote command and control into devices that are not PCs. And again, whenever you have a scenario like this, you're not talking one, you're typically talking tens of thousands, hundreds of thousands of devices, which then are sold in masses in the consumer market. So you have a command and control path on the right side, which is about a topic that sends into subscriptions. I'm going to detail that. And then you have a telemetry path, which also goes into the topic, into control analytics and event systems. Which brings me to the notion, before we debate all the other details, which brings me to the notion of scale units. And that's something, if you take something away from this talk, anything, and it's not specific even to service bus, take away the concept of scale units. A scale unit is a set of resources of which you know the exact characteristics in terms of throughput and scale. And you bundle them all together, and then you affiliate them with a fixed number of clients, right? Or a range of clients, but make everything predictable. Once you can control something that can handle 10,000 clients, you can do 10 million clients. But you need to have a predictable thing. So let me talk about that briefly. In this model here, where we have an air conditioning, and the air conditioning is being controlled, is in a house, and in a household. And you want to have an application that allows you to control that air conditioning from the household. You actually have a very simple partitioning model. Because you can go and partition either by device or you can partition by household, but those things typically are disjoint from each other. The power company will want to talk to a region or or everything in their coverage area. That's a different scale concern, and we're going to get to that. But typically, the first order of partitioning is often very easy in those systems. When you think about things that are, like when you think about Facebook. Facebook is easy to partition because everything is just about you. And if you're subscribing to someone, it's effectively pub/sub thing. You subscribe to 500 people's data of interest, and then as they are posting something, they basically post that also into everybody else's buckets. So it's a simple matter of keeping an account that transfers are being made into. But it's a single partition. Hotmail, Gmail, same thing. Also very easy to partition. Here, also easy to partition because you can partition on a per-device basis. So what we'll do is we're going to associate those devices, we're going to associate the air conditioner or the car with an ingestion topic. And that's a topic we're going to go allocate in Service Bus, and we'll affiliate that with 10,000 clients. And the reason how I get to 10,000 is I'm just doing a calculation of how much throughput can I get through that topic. And the numbers that we measure are around 2,500 messages per second as entity throughput. Entity throughput is how many messages can we actually pump through the topic, including all subscriptions. So if you have 2 subscriptions, you get a flow rate of 1,200. If you have 100 subscriptions, you get a flow rate of about 25 messages per second, flow rate through the entire system, but the overall throughput is 2,500. Rule of thumb. Your experience will vary a little bit. To make a super safe bet, we're going to say it's 1,000 messages per second. So we're going to cut that in half and say that's what we're going to calculate with. So we're saying every device is sending a message about every 10 seconds, leads me to 10,000 that I can affiliate. Because that's my safe notion of what I can do here. Then I have subscriptions that go into a storage writer, an aggregator, and into the control system. The storage writer writes into the event store. The event store is down in the table store. There I now have to see, do I have concerns about my write rate that I can go and achieve, right? Well, we're going to have partitions based on per devices, which means we have on a per partition basis in the table store 500 records that I can write per second. So that's not going to be a concern here, right? So effectively what you do in your system as you're planning it out, you see what your primary partition is, and then you effectively compose the pieces that you need for your system, and you try to figure out what is my throughput rate here for all the different pieces, and then you put that together as a scale unit. That's exactly what we do inside a Service Bus, kind of under the bottom of the iceberg, under the covers that you don't see, is we have those notions of scale units. And if you create a namespace, we're allocating you to one of our scale units that we have in the data center, and that thing has very well understood constraints in terms of scalability. It does, we have 32 node sizes, we have 96 node sizes, so we don't even do dynamic scale arbitrarily adding nodes. We have well-tested configurations, 16, 32, 48, 96 nodes, and as we see the warning signs go on in terms of capacity, we're just going to go and switch to the next tested scale unit configuration. So that's what we're going to do here. right? The problem is that you need millions and millions of devices that you need to be able to connect. And so for that, you need to have a notion what you want to do with the data, what kind of data are you getting, what's the telemetry, and what are you going to do with that telemetry. 3 things. The first thing is, see the red path, we're getting data, and that's the current temperature readings. We want to go and get the current temperature readings every, let's say, 5 minutes or 1 minute, depending on how fine-grained you want to have it. And then you put it into a storage writer and put that into event store. That is the original raw data that's putting into that event store. The purpose for that raw data is because for the customer who's now buying that air conditioning, but is also buying the companion application for their iPad or their iPhone or their Windows phone or whatever it is, they will go and they will want to have accurate statistics. They want to have their data and their events, and they want to be able to look at it because that's the value add that we're selling them. So they need to have all that data. The electricity company that wants to see what the trends are and how the temperature outside is affecting everybody and what are the consumption is like, they're not interested in the raw data. What they're interested in is accurate roll-ups of that data. So that's the second one. That's the aggregator, which is effectively just a process, a reader that pulls on that subscription and then rolls up that data. And we have a technology called Stream Insight, which is brilliant for that, which you can use as part of the SQL Server offering. You can actually also run that inside of Windows Azure if you have the appropriate SQL Server license. And then you can go and run that and roll up the data, do complex event queries, and then forward the aggregate every minute or so down further to further consumers. And then there's a control system that will take the commands that you send to the device, set the temperature to the following to 20 degrees, or turn it on, turn it off. That sends those control system commands out through the fan-out topic, but then also has a feedback loop done through that extra subscription. The fan-out topic has a subscription on a per-device basis, which is good for network going down. If you want to send a command to a device, you don't want that command to get lost, even if the device is on wireless and the wireless is probably not as strong. So you want to be able to have a little mailbox effectively that sits there, and you want to have that mailbox have the capability of also having a TTL. That's what we have in Service Bus, a time to live, so that you don't send a command and then that command gets stranded somewhere in the subscription because the client hasn't been able to connect for a while, and all of a sudden things turn on or off a day later. You don't want that to happen, so you probably want to have a TTL there as well. So that's kind of the exploded picture. Now we have the storage writer on the one side, you have the aggregators, and the aggregators now take the data and put that into a statistics topic. So they're pushing that data, they're pushing less data. We get tens of thousands of events from the top. We reduce them to a tenth of that. We're rolling them up, putting them into statistics topic, and then from the statistics topic we go into an analytics store and probably also into a real-time analytics dashboard. And with these kinds of fan-in models, you can go and do statistics from a very broad number of devices. Now, let me talk about the connections that are sitting up on top of those ingestion topics. The connections here are being made. They can be made very easily through HTTP, or to be precise, HTTPS, to just drop packets into Service Bus. It's very simple. In the future, in the near future, towards the end of the year, we're also going to introduce the AMQP protocol, the Advanced Message Queuing Protocol, which is going to make this significantly more efficient. For those small devices, it's actually, HTTP is very heavy. It's very heavy because it requires HTTPS, and actually getting HTTPS running on this, on the small device that I have here is very hard. Nominally, this device, which is running on the .NET Micro Framework 4.1 does support HTTPS, but the way, for instance, the Microsoft Cloud implements HTTPS, our concrete suite for algorithms, etc., is no problem for any PC stack. But that device actually doesn't support that. So I'm waiting for the update for the .NET Micro Framework 4.2 to actually do HTTPS properly against our system here. So for that, we're going to support AMQP, and AMQP is a very lightweight binary protocol that will be much better suited to, for instance, sending telemetry from small devices. And no? Ah, there it is. Command fan out is also interesting. Let me talk about that for a moment. And wait, am I missing a slide? Yes, I'm missing a slide. Command fan out. What you can do here is you have the control system, and you have these partitions, and you have per partition you have one or multiple topics, and each have the devices hanging off them by the ways of subscriptions. The control system will now send effectively messages to the individual devices into the topics, and then they will be filtered based on filters that are in the subscriptions. I'm going to show you that later as well. There's some extra wonderful options that you can use. So another feature which we're going to bring out towards the end of the year is forward to, a notion that you'll be able to hang off. Have a subscription, and that subscription immediately forwards all the data, all the messages that come into it, into something else. So with that, you can build trees. So you can build a topic, like the one in the middle, have a number of subscriptions, and that will then each subscription will automatically forward into another topic. So you can set that up, and with that, you can build a tree. Now, I talked about throughput limits, right? The throughput limits are based on, well, this is a reliable system and it's going to disk, etc. So let's say we have 2,500 messages per second on a single topic as a throughput limit. What you'll be able to do then is you'll be able to go and build a tree of a primary topic with a number of subscriptions. You hang other topics on top of this like this. So the control system here could be a topic with 3 subscriptions. And then you can drop one message in, it goes to the first stage, and then goes to the second stage, and all of a sudden you can build a system that does a broadcast with enormous throughput, because you're just using very, very, very many topics in parallel. That is actually how we're building the thing that I mentioned in my overview session, Iguazu, our push notification system. That is actually built using a fan-out tree like this, and we're going to give you that fan-out tree capability. Once you have a tree like this, it's actually very easy to individually address those devices. The first thing we'll do is you will send a message into the topic that has a device ID, or a household ID, or a neighborhood ID, or whatever the next structure is. And then in each of these rules that are associated with the subscriptions, you will go and test for the appropriate household ID or the appropriate device ID, etc., etc. So you can go and do unicast or groupcast or a broadcast very easily using a fan-out tree together with rules in the subscriptions. Now, what you'll also have to do, if you think about devices, or also if you're thinking about phones, is provisioning. And I'm going to let me back off from the air conditioning scenario for a moment and talk about phone, because this is something that's relevant for you if you're building phone-based solutions. If you need to have a mailbox for an application that sits on the phone, having that mailbox being a service bus subscription is actually a very good idea. So you want to have individual addressability for that thing. What we can do with Service Bus is we have fine-grained security on an entity-by-entity basis. That's something that I mentioned in my overview talk. What you need to do, though, is you need to go and assign that device, the instance on that device, the application instance on that device. You need to assign that a subscription. You need to make one. And then you also need to make it an account so that it can go and talk to that new resource, and that it also can go and send data in. So that step is called provisioning. The provisioning step is something that you can, and we have multiple cases for that we've seen. For instance, there's a large company that we're working with that's building a expenses application where they're just using their internal expenses system as is, but they want to extend that to Windows Phone. So what they're doing is they're building an absolutely fantastic expenses application where you can, as you are on the road, can effectively just take a picture of your current receipt and just send it. And the goal of that application is to have every interaction that you have with the expenses app to be 15 seconds. So just do everything as you're on the road and just scan things with your camera and then just go and submit them. And so they're doing that. They're interacting with the queue, but the problem is initial provisioning. What they need to do is they need to go and have a first run experience. The application is coming from the App Store, blank. And then the application comes up, it looks into its local storage, it says there's nothing here, so I'm uninitialized, and then prompts the user for their account. Then they go to a backend service, the backend service checks the account, and then goes to Service Bus, creates their respective entities, goes to ACS, secures those entities, and then gives the application a configuration package that it will then further use to go and talk to those resources. So the picture here is exactly the same. So let's talk about the air conditioner. The air conditioner talks to the provisioning service. So it wakes up, it looks underneath itself into storage and finds, oops, there's nothing there, and will then go and talk to the provisioning service, which will verify its identity. And each of those devices actually has a unique identity because it has a network controller, so it has a MAC address. So the MAC addresses of the shipped devices go into an allow list, effectively. And so as the device shows up at the provisioning service, it will report its MAC address, probably hashed with a company-wide key, so it's not that obvious. And then it goes into verification. Once it passes verification, it walks up to the access control service, it talks to the partition allocator. The partition allocator will now go and see what scale unit to place that device into. So we'll have the notion that we can go and have 50,000, let's say 50,000, or I said 10,000 earlier, so let's stick with that. 10,000 devices can be on one scale unit. So we fill up that one scale unit, and then we go stand up a new scale unit and fill it up with more devices. So we go and create affinity of devices to those scale units. So that's the job of the partition allocator, who knows which device is affiliated with which partition. And it will then go and walk up to the access control service, create a new service identity. It creates an ID for that device. We'll come back, we'll go to Service Bus, create a subscription, the mailbox for the device, and we'll then walk up back to ACS, and we'll go and secure, we'll set the send permission onto the queue so that the device can go and send data into the system or onto the topic. And we'll send a listen permission onto the subscription so that the device can listen on that subscription. Only that device will be able to listen on that particular subscription with those rights, or an administrator will be able to. So that's the provisioning step, and once you've done that, now you have a device and you have a configuration package. You can give that to that device, and now the device can uniquely go and talk to it. Another reason for doing the scale unit aspect here is that you have service identities stored in ACS, and ACS is actually doing pretty well with configured with 50,000 or 100,000 service identities. You don't want to push it over the limit and do 1 million service identities, because ultimately that's all happening in the same table, effectively, in a database, and within the same partition. So you want to keep that at a limit. So you don't want to go and over provision with more than 50,000 service identities in an access control namespace. And therefore, it actually makes sense to kind of constrain it to about 50,000 devices that it can hang on one of those scale units. So, but that's a general model that you can use for device or application provisioning, app provisioning, where you come in. If you need to have access for a particular device to a set of resources, then you can kind of use that pattern to go about that. Let's go and take a brief look at that model. I took that picture myself. And I have that here in my solution. This solution, you will be able to download those bits. You will be able to download from the MSDN magazine site on Sunday. So the next MSDN magazine, so the architecture discussion is on MSDN magazine today. So in the current issue of MSDN Magazine, which you can find on the MSDN site, today the article is there. You can read through the architecture discussion. Starting Sunday, there will be, so July 1st, there will be this code along with an explanation of the device code and how the provisioning stuff works. But I'm going to show you that today. Sorry, wrong computer. And specifically, it's in the backend web role is the provisioning service. And the provisioning service is being called from the device and gets the device ID. Now, notice something. Here's another tidbit. How I'm doing the communication here. Let's go to the service bus application. Let's go to the actual code that's on the device. So the device is using the .NET Micro framework. It's a small, tiny version of the .NET framework that compiles straight down to microcontroller code for a number of devices. And there's actually a platform SDK, how you can make it ported to other microcontrollers. So in this case, it's here, this Gadgeteer device. And as the application gets started, what it will do is it will check whether the network is there, here. And then if the network is not there, we're going to skip the provisioning for a moment. It will see, sorry, that's not true. One moment. In the beginning, so perform provisioning is being called from, well, I was actually at the right place. So it will check whether the network is there. If the network is there, it's going to go and get itself the local time. So there's another constraint that you otherwise don't have on a normal PC. This device has no battery, so it has no notion what the local time is. So you have to get the time if you want to do SSL, because SSL requires you to check the certificates, and for that you need to have a current time. So if the network provisioning is not completed, which is effectively looking down into the storage on the device of whether we have the configuration package, then we're going to go and perform the provisioning. Performing the provisioning entails the following step. The device creates a web request, and then it goes and gathers some data. And else you'll see what I'll do here is I'm adding the device ID into a header, and I prefix that with P. That's what I call NHTTP, non-hypertext transfer protocol. Not exactly a joke. What I'm doing here is I have a simple profile. I have two rules. It's HTTP, two extra rules. Don't send any entity bodies. No entity bodies are being sent. And all data is expressed as HTTP headers that are prefixed with P, which gives you clear enumerability. No JSON, because JSON is too complicated. It turns out that every HTTP stack can go and parse headers. So there's no need for an extra parser. And every HTTP intermediary is required by law, RFC 2616, the law, to forward all headers. Which means, why have JSON? So I'm just setting the header, and I'm sending that response. I'm actually making the content length 0, so this explains it. I get the header out. Look how easy that is. No JSON parsing, no XML parsing, none of that stuff. No serialization. I take the ID, I check the allow list, whether the device is in there. And if it's in there, then I'm going to go and create the service identity, which means I'm going to walk up to ACS and do that. Let's go and take a look at this. What I'm doing here is I'm using the code from the sample that we have in the SDK for the SBAZ tool. The SBAZ tool, the Service Bus Authorization tool, actually comes with a library. And so you can use that library. And with that, I'm creating, in the access control service, I'm creating a new identity. And then I can set the key, or I can use the key that's being generated for me, save it, and with that I have now created an identity over in ACS. And now I'm returning that into the device configuration settings. And then I'm going to create and secure the entity, so that's also then now using that data. So going here, creating security entities. What I'm doing here is I'm going to the namespace manager, which is the API in Service Bus to create and manage things in the namespace. And then I'm creating a SQL filter for the device where I say, if the device ID is this device ID, or there's a property that's called broadcast, and that's true. So either it's targeted or it's for everybody. Then I'm going to add that subscription to the device's topic. So I have a single topic here in my case to keep things at bay. And then I'm creating that subscription, taking that subscription out. And I have a special mode here that's just for these kinds of devices that can't talk HTTPS, where I'm having a pass-through service in here that will go and translate from a plain HTTP mode with a custom signature to a service bus so you can have a custom gateway. For the typical case, you will only have the normal HTTPS mode. And so what I'm doing here is I'm effectively I'm creating the URI for submitting events, that's a topic, and for the subscription that is now being generated for the device, and putting those into configuration, and then return that back. And after setting the permissions, also using that same API that's part of the SBAZ tool, onto the subscriptions. And then once I'm done with that, I go and set all that data onto my response and go back and reply to the client. And the client now has the configuration package it can go and store locally and can start talking to Service Bus. So that's the setup procedure that is needed to go and make that device go. It's not hard. And actually, the little NHTTP trick, it's a nice simplification, I think, for a lot of those kinds of communication passes where you only have a few simple key-value pairs to exchange. So with that, let's go and spend the last about 23 minutes on enterprise integration patterns and a number of patterns that you can go and realize and that we've been motivating with the examples up to this point. The first is a set of messaging channel patterns. The first one, the simple one, is pub/sub. Publish subscribe, that's implemented by the topic. The topic is a sequence of messages. And the sequence of messages, you can have multiple subscriptions. And theoretically, and actually also practically in our implementation, the way we are implementing a topic is by having 3 different server-side cursors that scroll over that log. So when you think about how a queue works, is you're creating a log ordered by time. It's ordered by arrival, exact time of arrival. We're actually stamping a sequence number on the messages as they come in. And then you have a cursor, and the cursor scrolls forward over that log. And that's how you get the messages out. And the cursor is shared. And so what we're doing here in pub/sub is we're creating multiple of those cursors. And every subscription represents one of those cursors. As you get a message from a cursor, it scrolls forward to the next message, forward to the next message, forward to the next message. Somewhat simplified, but mostly accurate. So publish subscribe, the sender broadcasts the event to all receivers. So, and I have, for most of those patterns, actually a few demos. So you create the topic, you create a subscription on the topic name, first, second, third subscription. And when you do this, you create a broadcast fan out. All subscribers get the same set of messages. So I'm going to go and show you that. So it's creating the topic. And now it has these 3 subscriptions. And we're sending the data into these subscriptions. And to actually have a rule here, there's whatever is not category 1. So we have a category 1 that's kind of part of the payload data. And then the one in the middle only gets whatever is for category 1. And then on top is an audit tab. It's an audit subscription. Audit subscriptions are subscriptions which are always true. They have a single rule that's a true filter. And they will simply get all the data. And that's one of the nice aspects of topics over queues is that you can have a subscription that sees all the messages. So if you need to do diagnostics, if you need to do auditing, you can always have that extra tab on the message flow, which is something you can't have easily on a queue. So that's pops up. And as an extension to that model, you can have a content-based router. We already kind of saw that, where you can route a message to different recipients based on the data that's contained in the message. So you have some order processing system. You want to go and route by a particular criterion. Then you can go and use that. So we have, this is what we actually just saw. So you create a topic, you create this auto subscription, you create the category 1 subscription, the category not 1 subscription. So you have these simple rules that you can go and create, SQL 92 dialect, and then you can set the properties on the messages that you send, and with that you can effectively distribute them to particular recipients. And you can make those rules fairly complex, and it's a SQL 92 dialect. We have that documented in the API with the SQL filter class. If you go and take a look at that, it actually lists out that language in its entirety. So we've seen that content-based router. The next thing is the recipient list, where you want to route based on specific vendors' departments. For instance, you can do filtering based on also like conditions. So you don't have to have an exact one. You can actually do some simple pattern matching with like. So I'm going to show you how that works and how that materializes. Let's do that here. So I have the sample for the recipient list here. So we're creating the subscriptions, and then we say when the property name for when the category has first in it or when it has second in it, then please match. So let's go and execute that. And now we're sending into either one of those categories. Oh, let me make that a little bigger because that's kind of hard to see in this way. So we're sending messages that are targeted either at the first or at the second, whereas you're stopping that early. So the first and the second and the first and the second category, and you'll see that based on the matching filter, this here is the audit subscription. This gets everything. This gets everything where first is contained, and this one gets everything where second is contained in that list. So it's using this like condition, just like SQL, to go and effectively do a pattern matching inside of a string expression, which is also very nice. And that's where you have a recipient list, a list of recipients, and the recipient is effectively putting its name into the condition, and with that filter set out. Right? Resetting that demo. Then we have some routing patterns. The first one is a splitter. The splitter is something that we don't have as in the model directly, so that's something you will typically have to implement yourself. The goal is you take one message and then you are breaking that message into smaller pieces so that they can be routed and they can be processed. Splitters are necessary in the system with Service Bus because Service Bus is constrained in terms of message sizes. We only allow 256 kilobytes. Before you get up and leave, there's a hard reason for that, and that is, well, we're a cloud-based system. And if I was allowing you to send me a gigabyte, then nobody else could send anything. So we'll have to find a balance between message sizes that we allow and scalability and all those concerns, because we have to keep that data in memory. We might go a little bit up in that. But if you're hoping for anything bigger than 1 megabyte, I'll have to disappoint you. We might go up to 1 megabyte, but I can't see us going much higher than that. So how will you deal with this? Well, you will have to go and split the data up. Now, what we will help you with is typically when you have a queue and you have multiple consumers on that queue, well, now your messages that you just split get scattered across the receivers. What you will want to do in the case where you take a single work set and split it up in smaller chunks is you want to keep it together. So the way we're doing that is we can go and keep it together using sessions. and sessions also help with aggregators. And aggregators allow you to do effectively, you have a splitter that splits things up, and you have an aggregator, we have multiple sources, and you all want to get them to the same receiver. We actually had that, so I'm going to talk about both of those. I'm going to show you both of those things. We actually had that in the case with the site that was tracking your social footprint. What they did is they sent a request out to multiple parties, and now they have multiple parties responding together responding to a single job, and that's aggregating that data now into a single stream. So now we need to be able to correlate all that data based on that single stream. So for that we have session support. So let's take a look at that. And that's the session messages sample. So the first step is what's happening when you don't have sessions. Now it's sending message to a queue that doesn't have session support. And what you'll see is that the data gets balanced across all these different receivers. So that's the normal mode. So if we were splitting the data up, if we had a splitter and we split the data up and then send it to those three receivers that are competing, you would get kind of this result where things are being sent and then get load balance across all those different receivers. And same with the aggregation case, where you have an aggregator and get the data in. Well, they would also be split up. But if you want to correlate it all to a single place, that's a little challenging. So I hope that we'll go and switch over into that new mode in a moment, or I probably have to do a little dance. Now it's switching over to the session mode. Session mode, it's now turning on requires session on the queue. So it's effectively creating a new queue and it's setting the requires session bit. And it will also here on the receivers, now it goes and demultiplexes. What it does in the code, I'm going to go there in a moment, is instead of receiving individual messages, it now accepts a message receiver. It's like TCP, where you first accept a socket and then you start receiving from that socket. Ultimately, what we give you with the session support is a multiplex demultiplex model through a service bus, through a queue, and also working through subscriptions. So both for the aggregator and for the splitter model, what we can now do is we can pin a group. We can pin a session of messages to a particular receiver. The receiver creates the message receiver, and then we're pinning everything that comes in with the same session ID to that particular client. And so they're now done with receiving, and they're going to try to pick up the next session, which now sits in there. Right? So they were just waiting whether there would be any more messages, gave up on that session, and now they're going and getting the remaining sessions out, the remaining session data out of the queue. So that's a very, very nice, very cool feature for creating multiplexing, demultiplexing, aggregators, splitters, and any of those patterns with the built-in session support that we have in Service Bus, which is unique for any of the Cloud Queue offerings anywhere that you can find. Well, you've seen that. So processing sessions, I'm going to show you that here. Instead of saying receive message, what you'll say on the queue client is you're going to say accept message session. There's also a begin and end version of that. It is the son of sockets, really. It's the same model where you have in the socket world, if you are listening on a socket, you say accept, and with accept you get a socket, and here you say accept message session, you get a session. From that you can then go and receive and process messages. These sessions are unbounded. So inherently in the system there's no begin and end to a session. So you can either treat them as a never-ending multiplexing, demultiplexing stream, or you can make your own begin and end markers. You actually explicitly send a message that starts the session and ends the session. So if you were, for instance, doing a file transfer in this way, you do a begin message, and then you do a content message, and you do an end message. And with that, you have a clear notion of when that session ought to end and when the processing of the messages needs to stop. So we leave that completely up to you, but they're completely unbounded. Now, what will happen if there's a crash? So let's say I'm pinning a session to me, and I'm now receiving data. Now the receiver crashes or loses the network connection. What happens then? We have a feature in sessions that's called session state. And session state, oh, something happened in formatting. OK, we'll have to deal with that. In each message session, so that's the receiver object you got out of here. That message session object has a get state and set state. That will go and place a bucket of state which is as large as one message, and it's binary. It's a binary stream, and puts that into service bus. So you could store your processing information about where you are in that stream. You can store that in service bus, and so someone else can go and pick it up. So if you go and start using a message session, what you can do is you can go and check for the state of that message session. If we have remembered any state of that message session, we will give you that back. And then you can go and evaluate that state. It's just a stream, so you can go and put any serialized data into that if you like. And then you process the message, and you process whatever you need, and then you can go and put that state back into the session stream. An example for this is the resequencer. The resequencer is using that for that purpose. But before I get to the resequencer, think about that for a moment. If you wanted to build your own, let's say you want to build a simple state machine, and the state machine is driven out of messages, and you simply want to do 3, 4, 5 things, but you need to process them over a long period of time. With this feature, with the session feature and the session state feature, we can do this. Matter of fact, we will have a new workflow. We will have a workflow service, or a new workflow, version of the workflow hosting service. That workflow hosting service, and that's not out yet, but I'm just telling you anyways, because for the next version of SharePoint, I don't know how they're going to call this, so I'm not going to announce anything here. But the next version of SharePoint sits on top of that workflow service, and that in turn sits on top of Service Bus. Workflow stores its state of the workflow inside the session state of Service Bus, because it's an ideal model. What they can do with this is effectively you accept a session, and the session ID is the workflow instance. Everything you send to a workflow instance, you just set the session ID to workflow instance ID. Accept the session, you get a message out. You process the message, which means you advance in your workflow. You save your state of the workflow, and you store that into the message session, and then you walk away from the session. Some completely different machine somewhere else, as long as it has the same workflow definition available, can now go and grab the session, take the next message, process that based on that code, and then put that back. So you instantly get massive scalability for compute work, because you can actually track the state for long-living processes very nicely inside a service bus, and that's actually what they're using that for. So the resequencer is a model that is using that kind of feature, the session state, to remember where it is on a sequence. So there's a sequence that comes in, and the sequence is now out of order. It's actually enqueued out of order because it comes from different parties, and out of order might mean that it comes out of the order that you can go and deal with it. So let's say you have a workflow that you want to go and process, and there's things happening in certain steps. You do a fan out to multiple partners. The partners come back with their documents or with their responses, but you have to process the responses in a certain order. So you get a message. The message now comes too early. You can't do anything with that yet. So you have to go and put it somewhere and get that message later. So that's what the resequencer does for you. And the resequencer will use the session state to actually restore this. So a message comes in, message 1 gets through, now comes message 2, message 3 arrives, we're expecting message 2, but message 3 arrives. Now message 3 is out of sequence. What we'll do is we want to put message 3 back into the queue, we want to forget about it, and what we're doing with that is we're deferring it. Deferring means I will put the message back into the queue, but the message will not by itself appear again as it does when I do a peak lock and I put the lock back. Defer means take that message back, but don't give it to me until I tell you. So you effectively explicitly then resume that message out of and you have a receive with the message ID. Now the question is, where do you store that message ID? We store it in the session state. And that's what the resequencer does. So we're going to take a look at the resequencer. And those samples are all available online in our code gallery. And they're all Apache licensed, etc. in that same setup, so you can actually run them all on the screen in that way. So I have those senders, and they're sending the data in. And now this guy, the receiver, is actually checking out the session. And what we'll do is it will now go and pick a session. So it picks the yellow one. And now it's getting messages in arbitrary order. And what it does is it goes and defers them, the ones that it doesn't have out of in order, and then puts them back, gets the next message, checks whether the message is in the expected order. If it is, it lets it through for processing, and otherwise it will go, and then it will go and retrieve the next message from the deferred message stack automatically. So you can go and take a look at that detailed code in, well, actually I have that here. So let's take a look at that code quickly. So in the session state object, we have a little object we store in the session state. We'll get the next sequence ID. If that sequence ID is not the same as the message ID we just got, so we are expecting a certain message ID, then we're going to defer it, and then we add the out-of-sequence message, the message we just recorded, and we add that to the list in that session state, and then we set the state, which means we update the state in the session. You can do that transactionally. So you can include that in the transaction scope, and you can go and complete the message, and you can set the state in the scope of a single transaction so you don't lose that message, which means process the message, complete it, set the state. So if we don't succeed in completing the state or setting the state in the system, then you will actually see that message again, because then it will actually be subject to the normal peak lock. And then otherwise, if we want to go and get the message again from the queue, then we actually need to go and specify that message ID, and we're going to grab that out of the message state. So then, of course, you can go and compose all those things. So you go and, for instance, have order handling, where you now go and get data from the separate sources, integrate them using the session feature into a queue, where you have all that data flowing in. Then you have a splitter that sits behind this, and then you send that into order processing. So you can go and take all these individual patterns and now put them together to make more complete systems. I'm not going to go through all that in detail, but it should be fairly clear that you can build fairly powerful systems and fairly powerful integrations just with those capabilities that we have built in, particularly with sessions, which is a really, really powerful feature to do these splitters and aggregations and all those things inside a service bus. It's a very, very unique feature that you won't find, that's not in MSQ, and it's not in any of the other cloud services that you can find. And if there should be, not that I'm announcing anything, but if there should be a version that you could run on your own server of that messaging engine, just guessing, then that will also have that feature. And then you have scatter gather, obviously. So you can send into a topic and scatter out to other parties. You go and set the session ID, effectively use the session to correlate, and then as you gather, you go and gather back into a single queue, which then now gives you that concentrated stream that you can then process. So scatter out, scatter in, and effectively as you're manipulating the session ID, you can do this. And we're going to have more powerful, as we're adding this forward to feature, you can actually go and knit those things together. Our rules allow, so the rules on the subscriptions allow not only specifying a filter, but also specifying an action. With the action, you can set a property. So, and you can have up to 2,000 rules on a single subscription, which means you can make very complex matching conditions and based on that manipulate the properties on the message as you route them forward. And combine that with the forward to capabilities where you can now actually build very complex routes solely inside a service bus with some fairly interesting complex processing. So that's what I had for you today. Well, probably a few seconds over. And with some customer use cases, integration patterns, and device integration. If you have further questions, I'll be come to the front, ask me here. I'll be sticking around for a little while and also outside. And thank you, and have a good trip home.